Hi everybody, in this video we're going to talk about some algebra because in Unit 4 we started out by discussing inverse trig functions. So I just want to review what we mean by an inverse function. So if we have some function f of x, and let's say we have the function f of x equals 2x cubed minus 1. In a lot of cases we want to devise a function that we call the inverse. And we denote the inverse by f to the minus 1 of x. Okay, and here the minus 1 power does not mean the reciprocal, so this is not 1 over f of x. What this is a function that reverses the action of f of x. Okay, so if we think about the function f of x equals 2x cubed minus 1, what does this do? Well, it starts with some input x, and it's going to end with some output that I'll call y. Now, how does it get from input to output? Well, if we think about our order of operations, we have three things that we're doing. We're multiplying by 2, we're cubing, and we're subtracting 1. So using our order of operations, we first have to cube, and then we have to multiply by 2, and then we need to subtract 1. Okay, and that's going to get us to our output. Okay, so that's going to be 2x cubed minus 1. Okay, so that's the order of operations. We put in an input, we first cube it, we multiply it by 2, so that's the times 2, we subtract 1, and then we're done. Okay, so let's suppose we want to reverse that. Let's suppose we're over here and we want to get back here. So we'd reverse our steps. Instead of going left to right, we're going to go right to left. So first we need to reverse the step of subtracting 1. How do we do that? Well, we have to add 1. And then we're going to reverse the step of multiplying by 2. So we're going to divide by 2. And finally, we want to reverse the step of cubing. So we would take the cube root. Okay, so in other words, if we were to start with an input of x, what are we doing? Well, we're taking our input, x, we're adding 1 to it, then we're dividing by 2, and then we're taking the cube root. Okay, so we need to completely reverse our steps in the reverse order. So again, we start with our input, we add 1, then we divide by 2, then we take the cube root. So our inverse function would be the cube root of x plus 1 over 2. Okay, so that in general is the idea algebraically of what an inverse function does. The thing you want to remember is that the inverse function will reverse whatever our original function does. Okay, so what does that mean for us graphically? Now, it turns out that there's a relationship between the graph of a function and the graph of its inverse function. Okay, so let's take, for example, the graph of the square root function. Okay, so let's suppose, f of x is the square root of x. And we want to think about what the graph of an inverse function would look like. And so if we were to take a point on the graph of the function, let's suppose we take the point 2 comma 4. Or sorry, 4 comma 2 rather. Getting ahead of myself, 4 comma 2. We know the point 4 comma 2 is on the graph of the square root function because the square root of 4 is 2. Okay, so when x is 4, y is 2. Remember, the inverse function is going to flip the input and the output. Okay, so if we have the case that, f of 4 is equal to 2, then it has to be the case that f inverse of 2 equals 4. And because we think about the inverse function as reversing the action of f. Okay, so if f sends 4 to 2, f inverse will send 2 to 4. Okay, in other words, the point 2 comma 4 has to be on the graph of our inverse function. Okay, more generally, if the point x comma y is on the graph of f of x, the point y comma x, so the point we get by flipping the coordinates, has to be on the graph of the inverse. Okay, and it turns out that if we take the graph of a function and we reflect it across the line y equals x, and this is not going to be the greatest picture here, so I'm going to have to move my points a little bit. So 2 comma 4 is kind of winging it here, so 2 comma 4 is going to be a little closer to here. So reflecting a graph across the line y equals x flips the x and y coordinates, and therefore reflecting across the line y equals x is going to give you the graph of the inverse function. So this would be the graph of y equals f inverse of x. And so if we take a look at this graph, this kind of looks like half of a parabola. So this kind of looks like the graph of the square function. And that makes sense because what reverses the square root? Well, it's squaring. But it's not the entire square root function. Because notice, when we do this reflection, we only get the part for x greater than or equal to 0. Okay, so that's how we would go about getting graphs of inverse functions. We would take the graph of our original function and reflect it, flip it across this line y equals x. And the line y equals x extends out this way as well. Okay, and then this issue of the square function brings us to the last point. And that is, not every function has an inverse. Okay, because we want to remember what it means for something to be a function. In order for something to be a function, its graph has to pass the vertical line test. What that means is every vertical line passes the graph of the function at most once, intersects the graph of the function at most once. And that means that for every x, or every input, there is at most one y, or one output. So f inverse x exists if f of x is 1 to 1. So a function is 1 to 1 if it passes the horizontal line test. Okay, or equivalently, no two x's are sent to the same y. Okay, so for example, with the horizontal line test, that means that every horizontal line intersects our graph at most once. Okay, so a graph like this, like the graph of x cubed, is fine. On the other hand, the graph of y equals x squared is not okay, because we have a lot of horizontal lines that cross the graph twice. Equivalently, no two different x values can be sent to the same y. So for example, with y equals x squared, we think about x equals -2 and x equals +2. Those are both sent to 4. -2 squared is the same as 2 squared. And therefore, y equals x squared is not 1-to-1. Okay, and therefore, it does not have an inverse, because the inverse function reverses the order of our arrows, and any inverse function for x squared would have to send 4 to both -2 and +2. And functions cannot send one input to two separate outputs. A function can only send one input to one output. However, we can take a function that is not 1-to-1, like x squared, and make it 1-to-1 by restricting the domain. So the way we could do this would be to instead, think of what we had with that graph of the square root of x and its inverse, and just look at the function x squared restricted to the domain x greater than or equal to 0. Okay, so the graph would look like this. It passes the horizontal line test, so it is 1-to-1. Okay, and its inverse function is going to be the square root of x. Okay, so I'm going to leave this as it is. In the next video, I'm going to start out by introducing the relationship between domains and ranges of functions and their inverses, and then we'll start to talk about inverse trig functions.